All right, hey again, guys. Video 2 of 2 for this lesson. In this video, I'm going to talk about something called paragraph proofs, which you're now invited to start writing in place of proofs if you'd like. Most people like writing column proofs because they are a lot more structured. They're a lot more easy to reread and make sure you did something correctly. But that being said, you should know about paragraph proofs because they might be easier and more quick to write in certain situations. I'll get to that in a second. And also, furthermore, right, in future textbooks in college, proofs of theorems, right? Remember, proofs and theorems are just facts. Remember, proofs of theorems are facts. They're mathematically proven facts. Proofs, the way that an author of a textbook will make the case that something's a fact for you guys in college and beyond isn't going to be broken out into 2 columns. The way your book is doing it right now is to make it really, really structured for you and make it very follow a chain of reasoning that you can follow from step 1 to step 10 to step 15 even. But paragraph proofs are going to be kind of how textbooks in college will be written. It'll be like, here's our premise, and then this is going to follow from it. Let me explain to you why by writing out sentences, and then we'll start this here. So your book does these kind of simply, and you'll start seeing this too when we get to new theorems. They'll start writing out why a geometric fact is a fact, and here's why, right? Written out as a paragraph or 2 here. Okay, so let's check it out here. Let's try to write a paragraph proof for the thing that we just wrote. The 2-column proof for in video 1. And you're welcome to do this when it says, hey, prove this in the future, right? Prove this. So you still have to draw a diagram out. You still have to draw given premises. I might actually write this one out. So you still have to write this out and draw this out. Those are requirements. Okay, but you can answer your proof in paragraph form, which we'll get to in a second. And what might help us is that we actually spend a second writing out what I've written here to prepare us to think about paragraph proofs and what do we need to include in here. Okay, so what it says here is one other idea that comes up in section 3.7 is that you may begin writing proofs as paragraph proofs instead of 2-column proofs that we did all of fall semester. A paragraph proof is sometimes easier to write as you can, and this is the big thing for you here, you can skip writing about things that are supposed to be really easily assumed by the reader of the proof here. Okay, so there are some things that are very obvious that we say in 2-column proofs that we don't really need to say. So for instance, do we need a reason to say that AC is equal to AC? Sure, that's the reflexive property of equality, but do we need to always be writing reflexive property, or can we trust our reader to realize why AC equals AC? Are we allowed to say that? Okay, so let's check this one out here. Here are some things you can skip if you choose to write a paragraph proof instead of a 2-column proof here, okay? One thing in a paragraph proof you don't have to write, you don't have to state your givens. Oh my goodness, that's so nice. So you know how the first step of every proof essay is just, hey, write your given premises and proof statements here, draw your diagrams. First step is you gotta write the freaking given premises again. If you write a paragraph proof, you don't have to write your givens, okay? So 2-column proofs, you gotta write those givens out at the beginning, right? That should appear at the beginning, that you're using that in your chain of reasoning. Here, it can be assumed you're using the given premises here, okay? So you don't have to write the givens here because they're written up top here, and we can start talking about why we know that AC is perpendicular to BD right away, rather than just restating something that is a given premise of the problem. Second thing you don't have to include, okay? Second thing is that you don't have to cite your specific reasons for a property of inequality, okay? So for example, if you're adding 2 things to 2 sides of an equation or something like that when you're writing it out, you don't have to say, the reason I could do this is by the addition property of equality. Or say if you knew that AB equals CD, and you wanted to say 2AB equals 2CD, you don't have to write out multiplication property of equality. You can just say here, since I know AB equals CD, then 2AB equals 2CD. So you don't have to write here. So the 2 things you don't have to write in your proofs anymore are your given reasons, and then you don't have to say the specific reasons for properties of equality, okay? So you don't have to actually say reflexive property. You don't have to say substitution property. It can't hurt to say these things, but you don't have to do it, okay? So let's just see in practice. Let's write ourselves a paragraph proof example for this one right here, okay? Do we have to start with our givens in the paragraph proof? No, we don't, okay? No, we don't. So what we can do is we can start making a case here, which is that, remember the first thing that we did in this proof here? We wanted to prove that these 2 triangles were congruent. Okay, this triangle up top here, this triangle down here, we wanted to prove those 2 triangles are congruent. And the reason why we were able to do that is because angle 1 was given to us. I would still mark this up. You're not doing this for your reader, you're doing this for yourself, so you can solve the puzzle here. Angle 5 congruent to angle 6. Okay, so we can just start the proof by proving, remember we proved these two triangles congruent. The top triangle is congruent to the second triangle here. Okay, so what we can say is that since, okay, so we have givens, we might as well mention them because the reason we need to use the givens to state that that triangle is congruent to that triangle. But since we know that angle 1 is congruent to angle 2, angle 5 is congruent, now I'll do an and symbol there, and angle 5 is congruent to angle 6, and we see that AC equals AC, then we know that triangle ABC is congruent to triangle ADC by ASA. Okay? So this here is our paragraph proof that I've just started out here, okay? So you notice what we're doing here? This looks a lot more like an English class, right? That's talking about reasoning, right, within shapes, okay? Not really math yet. We're just reasoning with using shapes here. So we're just writing out in sentences here. Why do I know that two triangles are congruent by SA? Well, we knew that the angles were congruent here, this angle's congruent here, and we see that AC equals AC. We don't have to say reflexive there. That's save a word or two there. Then we know that triangle ABC is congruent to triangle ADC by ASA. Okay, so we said all of that kind of in that order up top in a two-column proof. But here we said that those first three steps in one sentence down here in the paragraph proof. Okay, so you can kind of pick which way you want to do this, two-column proof way or paragraph proof way. But a lot of people might think this is easier, might think this is faster. I leave it up to you to decide. Okay, so now that I've proven that those two triangles are congruent, I've given all my evidence here. I need to then give more evidence about why. Second step in order to get this was, remember, our second big step, key step, right? Key reasons to really get that triangle was congruent to that triangle by reason of we used SAS on that one. Okay, so the way we would do this with SAS is if we remind ourselves, the two green triangles, we wanted to get by CPCTC AB congruent to AD, right? Remember, we did that here. So just like this is a chain of reasoning, step by step by step, proving it through in a two-column proof, a paragraph proof is also kind of step by step by step, but it's a lot more loose, right? Like you can just write it on out why you know it's true, okay? By ASA. So another triangle is going to be by ASA. So here we use words like therefore and thus a lot, okay? Thus, AB equals AD by CPCTC. And then we think that's good because we know, right, since AO equals AO, we don't have to say reflexive, which is nice here, okay? We prove that triangle ABO is congruent to triangle ADO by SAS. By SAS right here, okay? So again, this is loose. I'm kind of choosing the words that I think make sense to me, right? Makes sense to me to kind of prove this one here. But the key things remain. To prove two triangles are congruent, I had to use CPCTC to say that those lengths of those side and the length of that other side here equal each other, so that then when I said that side is the same as itself, I have proven that these two triangles are congruent by SAS. Okay, so again, same thing as a two-column proof right here, but a lot more loose. If you notice something is congruent by SAS, you just gotta kind of say it out, right? You kind of gotta write it out and just let the reader know why you know the two triangles are congruent, right? Without neglecting anything that needs to be said in there, okay? So now we have the two triangles congruent by SAS. So now what I can say here is that, angle 3 would have to be congruent to angle 4 by CPCTC. And look at that, right? Big thing in this section again is to get double CPTTCs going. Be really geometrically awake, my friends. And then once we have that, so those two angles are congruent by CTC. And since they are congruent adjacent angles formed by line AC and BD, then we know that AC is perpendicular to BD, and my paragraph proof is done. This was ultimately my goal of what I wanted to prove, and I did prove it in paragraph form here, okay? So I got angle 3 congruent to angle 4, and then since those were congruent angles that were formed by intersecting lines, right, AC and BD, then I would know that those intersecting lines would have to be perpendicular on there here. So if you notice here, my last sentence of this proof, I don't even say that the official theorem that's for this there, but I explain via the theorem, right, that because I have these angles and they're adjacent angles and they're formed by intersecting lines, and I just say what the lines are, I don't actually write intersecting, I know that those two lines would have to be perpendicular to one another because we have a theorem for that, and the reader knows that, right, if they've made it this far in the textbook, okay? So there's my example of a paragraph proof. This might seem like a lot right now to kind of worry about and do, but perhaps, right, you play around with this a little bit. And perhaps you try to write some stuff in paragraph form. Perhaps we'll see some stuff on the Jam boards that people are writing in paragraph form. And we'll be like, you know what, this is a little bit easier and saves you some time rather than doing the 2-column proofs that we have here. Okie dokie, tonight's homework, we got Tuesday, January 5th, section 3-7, pages 144 and 45. Classroom exercises 1 through 4 all, written exercises 2, 3, 7, 10. I don't think any of these problems would take you more than like 5 minutes, let's say. Maybe one of the proofs takes you up to 10 minutes because it's a while. I don't know. There's 4 problems there, 5, 6, 7, 8 problems. So if they did take you the full 5 minutes each time, you're looking at like 40 minutes of homework, which is kind of a lot, right? Geometry is kind of extra in this class, but you got to do like 7, 8 problems at least, really, to get a sense of what this academic discipline is like here. If you need some help, right? If you need some help right now, I'm going to go through a couple of examples for you here.